All right, so go ahead and load up what you have from last time from on the if statement activity, and we'll work on that. All right, so I think the last one that we did was the triangle tester, if I'm correct on that. So let's just kind of revisit that one. So that one said basically you can tell if something is a valid triangle if the sum of any two sides is greater than the third side. So we said that had to be true for like all three sides, right? So and so this is how we did that. If S1 plus S2 is greater than S3 and S2 plus S3 is greater than S1 and S1 plus S3 is greater than S2. If all three of those things are true, then you know it's a valid triangle, right? So you have to get true on all those. Else, it's not a valid triangle. Okay? So one thing that I think is kind of interesting, there are different ways to write logically equivalent if statements. So, I mean, you could basically accomplish the same thing by going about it a different way. So check this out. And it's interesting. Every once in a while, I have a student that kind of thinks differently than maybe most people or whatever. So can anybody think of a different way to go about this? So how about this? Instead of, well, what are we actually testing there? We tested to see if it was a valid triangle, right? So check this out. You could go about it in a different way. You could test to see if it was not a valid triangle. And if you eliminate that possibility, then it must be a valid triangle. Does that make sense? So you could kind of rewrite this like this. We could have said, basically we could take kind of the opposite of everything. So we could say, in fact, I could just copy and paste that, and that would be easier. So I'm going to copy all this. Control C to copy, Control V to paste. And so what I'm going to do is I'm going to test to see if it's not a valid triangle. So this is what I'm going for, not a valid triangle, and then on the else, that would mean it is a valid triangle. So how could you test to see if it's not a valid triangle? Well, we could basically kind of take the opposite of things. So what is the opposite of greater than? If it's not greater than, it's less than or equal to, really, right? So, and I think there's a term for that. It's like the contrapositive. Has anybody heard of that? Of a sign? So if it's not greater than, the other alternative is that it's less than or equal to. So we can change all of these to less than or equal to's. All right. And then there's one other thing we have to do. What? Anybody think of that? So we're testing to see if it's not a valid triangle. So how do we know if it's not a valid triangle? If any one of these three things is true, then it's not a valid triangle. So we need to change all the ands to ors. And that's, remember, that's the pipe sign. So you have to do shift and the key that has the backslash on it. That guy. So if S1 plus S2 is less than or equal to S3, or S2 plus S3 is less than or equal to S1, or S1 plus S3 is less than or equal to S2, if any one of those three things is true, then it's not a valid triangle. But if all those things are false, then it is a valid triangle. So these two if statements, these two versions end up accomplishing the same thing. They're logically equivalent, but they go about it a different way. And we could test that. We could compile and run that. We should get the same thing twice. So we said that 1, 2, and 3 were not a triangle, right? Not a valid triangle. And it doesn't matter what combination or what order you put them in. Should do the same thing. But we said, what, 3, 4, 5 is a valid triangle. So what do you think? Oops. So there's different ways to go about it, right? Do that one more time. Cool. Questions about that one? Very cool. All right. Let's look at the next one. So I'm going to comment this one out. So again, I'm just going to go to before that one and do a / asterisk, and I'll do asterisk / right at the end of it. So that's commented out now. It won't get done. All right. So the next one. This is, I'm going to put a comment and say this is number, if you number them, this would be number 7. So this is Podunk University. Not the school. All right. All right. So this one says, at Podunk University, a student is enrolled in a course in which the final grade is either a P for pass or F for fail. The grade is determined by adding the scores obtained on 3 tests, T1, T2, and T3. If the sum is greater than 225, a grade of P is assigned. Otherwise, an F is assigned. Input the 3 test scores and assign an appropriate grade. So when it says a letter grade is assigned, that implies to me that we have a variable that we're assigning that to. So we need some variables here. So let's declare some variables. So we'll just make them integer test scores. How about, so we said T1, T2, and T3, like that. And a character variable to assign a letter to. So how about letter? There you go, character, letter. And we're going to ask the user to enter in the test scores. Cout, enter 3 test scores. And cn T1, T2, and T3. Like that. And then we're going to assign a letter grade based on that. So this one's not that hard. So this is one to try not to overcomplicate here. What does it say? If the sum is greater than 225, so how would you write that? Sum means atom, right? So if T1 plus T2 plus T3 is greater than 225, not greater than or equal to, it says it's greater than, then a grade of P is assigned. So letter is equal to P inside of single quotes. Right. Otherwise, so else, letter is equal to F. Now that's going to assign a letter. If you want to actually see what the result was, you can do something like this. Cout final letter grade, colon, maybe followed by letter, indel. So I'm trying to remember what that comes out to be. Maybe around a 75 average or something like that. 225 divided by 3 is 75. So they have to get a little bit above a 75 average. So at this particular school, it's like all or nothing. So when you run that, you get 75, 75, and 75. That's not good enough. So you get an F. If you were to get something like 75, 75, and 76, that puts you above 225. All right, let's do the next one. So I'm gonna do the same thing. I'm gonna comment this one out. Oops. So / asterisk and then asterisk / there. Right, so this is the 8th one. So the last two here deal with a salesman and calculating his commission. So this is number 8. This is salesman 1. So we'll call that one. So it says, a salesman 1 receives a commission of 10% on all sales if he has sold at least $10,000 worth of merchandise in a pay period, but only 8.5% if his sales are below $10,000. Input data containing the amount of sales, compute the commission, and print the commission earned. Okay. So we need some variables here. Let's make these doubles. They have their money. Okay, so I'm going to name it sales 1 because the next one is a salesman 2. So sales 1 and commission 1. Okay. And then we're going to input the amount of sales for that guy. So something like cout, enter the amount of sales for salesman 1. Something like that. And then cn sales 1. So this one again is it's not too complicated. He gets 10% commission on all sales if he sold at least $10,000 worth of stuff. So we need to test to see if he sold at least $10,000 worth of merchandise, right? So how would you write that? At least, what does that imply? Right, greater than or equal, good. So if sales is greater than or equal to 10,000, so no commas or dollar signs or anything in your numbers. If sales is greater than or equal to 10,000, then what? Commission 1 is equal to %, right? Sales 1 times 0.1 is 10%. Else, if he doesn't do that, then he only gets 8.5% commission. So commission 1 is equal to sales 1 times 0.085. So you have to divide it by 100, right, to get the convert that percentage to decimal. So that'll calculate it. Then we probably want to output that. So we could have a couple cout statements. Cout maybe something like sales amount followed by a $sign, and then sales 1, something like that, and then see out commission earned, and a $sign, and commission 1, something like that. If you want to, since this is money, we might want to output to 2 decimal places. We know how to do that now. So we could throw this in there right before we output stuff. See out, fixed, show point, remember all this stuff. And then set precision to 2. So again, that puts it in fixed notation, forces it to show the trailing 0, and outputs to 2 decimal places. Because if you don't do that, I'll comment that out so it doesn't get done. Depending, I have an error. If sales 1, sorry, sales 1. That was the name of the variable. If sales 1 is greater than or equal to 10,000. So, what was it, 10,000? Amount of sales is 10,000. His commission earned is 1,000. You should notice that it didn't show the 0.00 or anything like that on that one. So by default, at least with this compiler, it doesn't show trailing zeros. And then let's try it with less than 9999. All right. So there, it didn't show the trailing zeros on the sales amount, and it went to 3 decimal places by default, I guess, on the commission earned. So if you want to control that more, we can do something like this. So now if I put 9999, it shows the 0.00 and to 2 decimal places. There you go. I'll leave that up there. Anybody have any questions about that one? All right, let's go ahead and look at the last one. So I'm going to comment this one out just like I did the others. Wait, still going right? All right, so / asterisk, asterisk /. And so the last one here, this is number 9. Salesman 2. So this one's worded kind of, it's kind of vague on the wording, but anyway, we'll talk about it here. Input the amount of sales and compute and calculate the commission for salesman 2. He is assigned a commission on the following basis. So it has this table here. 0 through 500, he gets 2% commission. Over 500 through 5,000, he gets 5% commission. Over 5,000, he gets 8% commission. Right? So I think in reality, the way that it would work in business is like if you sold $6,000 worth of stuff, you'd probably get 8% commission on everything. That's probably kind of the incentive to sell more, right? But just to make it a little bit more interesting and a little more challenging maybe, I want to interpret it this way. So suppose he sold $6,000 worth of stuff. Let's say that he sold $6,000 worth of stuff. We're going to give him 2% commission on the first $500, and then 5% commission on everything he has in that second category, which would be $4,500 if he's over 6,000 or over 5,000, whatever. And then 8% on everything over 5,000. Does that make sense? So that'll make it a little bit more interesting and possibly challenging there. So we're going to go about doing this the same way. In fact, we could probably copy and paste some of our code here. So I'm going to copy all this, including the variable declarations. All right, so this is salesman 2. I'm going to rename these variables. Instead of sales 1, I'm going to name them sales 2 and commission 2. And we will output enter the amount of sales for salesman 2. And we're going to input that amount into sales 2. Okay. And let me just go ahead and take out this if statement because we're going to write that. And then down here, we'll do cout sales amount and change that to sales 2 and commissioned 2. See what I did there? That way I didn't have to type all that in again. All right. So we're entering in his sales and we're going to compute his commission. So let's test that first range, 0 through 500. So that implies to me that it includes 500. And so this is very similar to the range tester if statement that we wrote earlier, right? We're basically testing to see if sales 2 is within that range. So it would work the same way. We'd say something like if sales 2 is greater than or equal to 0 and sales 2 is less than or equal to 500. So remember, you don't have to have the inner parentheses technically, but you have to have the outer ones. I like to put the inner ones a lot of times to just, I think it makes it a little more readable. So sales 2 is greater than or equal to 0 and sales 2 is less than or equal to 500. Then he's in this first category and he gets 2% commission, right? So his commission, so commission 2 is equal to sales 2 times 0.02, right? He's in that first category. And then, but if that's not true, we need to check to see if he's in the second category, right? So else, if sales 2, so over 500, so that's greater than 500, right? If sales 2 is greater than 500 and through 5,000, sales 2 is less than or equal to 5,000, and he's in the second category, commission 2 is equal to, so we said we're going to give him 2% commission on the first 500. So if he's in the second category, he's sold at least $500 worth of stuff, right? So that part is pretty easy. So that would be 500 times 0.02. Okay? But then how much has he sold on top of that? So when you say plus, he's going to get 5% commission on what he sold on top of that. So how much is that? Well, that's sales 2 minus 500, right? And you want to give him 5% commission on that, times 0.05, like that. Does anybody see any issues or any potential problems with that? There is one. I'll give you a hint. It deals with order of operations. Yeah. So over here, sales minus 500 times 0.05. The way I have it written right now, it's going to do the multiplication. Multiplication takes place before subtraction, right? So it's going to multiply 500 times 0.05 and then subtract that from sales 2. I'm sorry, sales 2. Right? From sales 2. I don't want that. I want it to do the subtraction first, right? So we need that inside of parentheses. So we can just fix that really easily, like that. But that's one of those things that it wouldn't give you an error on that. You just get the wrong answer. Does that make sense? So 2% on the first 500, and then 5% on everything on top of that. So that's sales 2 minus 500, multiply that times 0.05. Good. And then that third range, we could test that if we wanted to. Else if over 5,000, right? Else if sales 2 is greater than 5,000, commission 2 is equal to, so we say we'll give them 2% on the first 500. So that's just like what we did a minute ago. 500 times 0.02. We'll give him 5% commission on that second range. So if he's in this third range, he sold at least $5,000 worth of stuff, so he'd have $4,500 in that second range, right? So that's 4,500 times 0.05, like that. Plus we're going to give him 8% on everything over that. So that would work just like what we did a minute ago. So it'd be something like this: sales 2 minus 5,000 times 0.08. But just like before, you need to group that subtraction inside of parentheses, like that. And don't forget your semicolon at the end. Just for fun, if all three of those things are false, what must have occurred? You'd have the only way you'd get if all those were false is if sales 2 was negative. So hopefully you don't have that, but just for fun, if you did, else you could do something like check this out. So you could do commission 2 is equal to 0. Commission 2 is equal to 0. And you could output a message. See out, you had negative sales. You are fired. So what's the problem with the way I wrote that? So there I've got two lines of code that I want to go inside that else statement, but I don't have them grouped within curly brackets, right? So if I compile and run this, he's always going to get fired. So just suppose he sold $6,000 worth of stuff. It says, you had negative sales, you are fired. But then it says his sales amount was $6,000 and he gets the commission, right? So again, it's thinking that it's more like this, if you want to see it visually, right? That's how it gets executed. Because if there's no curly brackets grouping statements, then only the very next statement is considered to have gone with the if or the else. So if you have multiple statements like that, you have to put those inside of curly brackets. like that. There you go. No fired message. All right. Y'all ready for something else here? All right, so I'm going to comment that one out. That's all of the ones on the sheet, right? Oh, did we? Oh, yeah. Okay, let's go back and do 5. Thank you. Yeah. So let me comment this one out. I'm going to go back and see if I can figure out where it should have gone. Let's see. Here was 6 was the triangle tester. So 4 was the range tester. So we have comments. The way I did it, that space in between is not a comment, right? So number 5, this one was kind of boring. That's why I skipped it. It says, develop a program that reads in 2 integers a and b and then determines whether the product of the 2 numbers is greater than 1/2 of a. So let's see, I'll put a comment here. This is number 5. This is the, I'll just call this one product of a and b. I don't know. All right, so we need a couple of variables, int a and b. We'll ask for those. Cout, enter 2 integers, and cn a and b. All right. So what does product mean? Multiply, right? So if the product of the 2, if a times b is greater than 1/2 of a. And so on this one, again, this one's kind of vague. And so if we do this, a divided by 2, because a is declared as an integer, it's going to do integer division on that, right? So if that's not what you want, then you need to do something like divide by 2.0 or multiply times 0.5, either one. So I'm going to do that. If a times b is greater than a divided by 2.0, what do we do? True, right? Something like cout true. Else cout false. So enter 2 integers. True. In fact, I think it'll be true for most things. Let's see. Can you think of a situation where that's going to give you a false? How about if b is a negative number? If a is a positive number and b is a negative number, that'll give you a false, right? Because the product will be a negative number and the half of a would be a positive number. 3 and -2 or whatever. So I'm not sure what the point of that one is, but that's how you would do it. I'm going to comment that one out. Oops. Let's talk about switch statements. So that's not on this, there's not a question about that, but let's get a little practice. Do I need to go back? Sorry. All right, let's go down to the bottom and let's add some stuff. So we're going to practice writing a switch statement. I'm going to comment here, switch statement practice. So do you guys remember what a switch statement is? It's kind of an alternative way of writing a certain type of nested if statement. So suppose you had something like this. Int month. So we have a variable named month. And I'm going to say cout, enter the month number. And cn month. So suppose you had an if statement that looked something like this. If month is equal to, two equal signs, right? Equal to 1. Cout January. Else, if month is equal to 2, cout February. You probably see where I'm going with this. I'm going to do this. Else if month is equal to, and then I'm going to leave it blank. I'm going to do some copy and pasting. Cout, nothing, indel. I'm going to copy and paste that guy. So there'll be March, April, May, June, July, August. You don't have to do all of them. I lost count. So what are we doing? We're kind of testing the same variable over and over again, right? So this was 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have too many. You could have an else by itself and do something like maybe else cout invalid month. And I need to go back and put all the months in. If I was smart, I would have chosen something with fewer than 12 things. Where are we at? March. April. May. Okay, let me test that, see if that works. Where did I mess that up? Else if month is, oh, these are numbers, right? Sorry about that. Fail, coding fail. So month is an integer. These are not strings. Here's my delete key. Here it is. Sorry about that. And even worse, I did that before I copied and pasted. Okay. Here we go. So enter the month number. We're in October right now, so 10. So it outputs October. Should work for any month. April. If I put something in there that's not valid, like 13, invalid months. All right. Sure. So that's a nested if statement, and we're kind of doing the same thing every time, right? We're testing the value of month over and over again for looking for a match, right? Looking for an equal value. So that's a perfect candidate for a switch statement. So after we get that going, we're going to rewrite that as a switch statement. So let me know if I need to move down. And also, remember, it's 2 equal signs, not equal sign, not 1 equal sign. What happens if you put 1 equal sign? We'll do assignment. Just say on March I messed up and just put 1 equal sign. Let's see what that does. I type in a 3. It outputs March, but then it also assigns a 3, but it's already 3. That's not a very good example. But anyway. Okay. So how could we rewrite that as a switch statement? So here you go. This is what it would look like. So again, we're testing the value of month over and over again, right? So you put the word switch, S-W-I-T-C-H, and then inside of parentheses, the variable or the expression that you are testing to look for an equal match. In this case, it's just month, right? We're looking at months. And then you have open and close curly brackets. So the whole thing goes inside of curly brackets. Yeah. And then you basically, the different cases are your different possible equal values. So it looks like this. And you can do some copy and pasting as well. So it'd be like a case 1. That was the first possible value. So again, I'm listing out the possible values. I'm not just numbering my different cases. Okay. On this one, it happens to be 1 through 12. But if you're doing like character variables or something like that, you put like case A or whatever inside of single quotes and that. So if it's 1, what do we want to do? We want to say see out January, right? And then you need a break in between each one of these. If you don't have a break statement in between your different cases, then it's going to skip down to where it finds a match, and then it's just going to keep going through the statements until it gets to a break or the end of the switch statement. So it'd be like case 2, see out February. Break, like that. So we can do some copy and pasting here. See out whatever, followed by break, something like that. Let's see if I did too many or not enough. Case 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, just right. And then we're going to output the corresponding months. March, April, May, so forth. All right, how about the else, the last alternative else? Like up here we had else, see out invalid month. So do you guys remember what the last option or whatever on a switch statement was? That's your default. So you put the word default colon, and then see out invalid month, like that. You don't have to have a break on the last thing. If it gets down to the default, it'll just go into the next thing afterwards. So let me test that. So we should get the month twice, right? So October. April. Invalid months. There you go. So what do you think? Is it less to type? I don't know. It's probably about the same, don't you think? I guess the advantage is, one advantage is, possible advantage is that maybe it's easier just to glance at that and see what's going on, you know, as opposed to this. But anyway, it's just a kind of a different selection structure and different way of writing it. The if statement is like the most versatile type of selection structure, right? You can write any kind of selection structure pretty much as an if statement. The switch statements, they're really ideal for a certain type of if statement, right? Where you're testing something over and over again for an equal value. You can't really do, real complicated things with a switch statement. I mean, you probably could, but it's probably easier to understand writing it as an if statement. So again, what happens if you don't have the breaks? So suppose I didn't have this one on April, or the one on May, or even June. What if I'd left those off? Well, if I type in maybe like a 5, it'll skip down to case 5, output May, but if there's no break, it's going to keep going. It's also going to output June and July, and then it'll break out when it gets to this break statement. So I said 5. There you go. The first May was from the if statement, and then May, June, July is from the switch statement. If you'd done 4, you get all that. So that's why you need the breaks. Now sometimes you could use that thing to your advantage. So check this out. You don't have to type all this, but what if I did something like this? What if instead of outputting the month, I wanted to output, is it like winter, fall, spring, or summer, or whatever like that? Check this out. I could do something like this. And we'll say winter is comprised of December, January, and February, okay? All right, so I'm going to put a break here. And we'll come back to winter in just a second. But just suppose we're going to say spring is comprised of March, April, and May, okay? So I could do something like this. And summer is going to be June, July, and August. And fall, we'll say, is September, October, and November. Of course, the problem comes with winter, right? So if I'd done this, see out winter like that, I've got them. So if it's January, February, it'll go to one of these guys and output winter, but I don't have anything down here on December, right? But there's nothing saying that you have to list these in the numerical order or anything like that. So I could stick 12 up here at the top if I wanted to. Case 12, like that. And I need a break here after the fall, don't I? So now, let's see what that does. If it's, just say the month is 3, right? It's going to skip down to case 3, but there's nothing there on case 3, but there's no break either. So it'll just keep going until it gets to the break or the end of the switch statement. So it'll keep going down and then output spring. So by doing that, I didn't have to type cout spring 3 different times, right? So let's test that. So let's just say October 10. So fall. So what did it do there? It skipped down to 10, but there was nothing there on 10, so it just kept going output fall. And then the break broke out of the switch statement. Or if you did 12, there's your winter. So sometimes you can actually use that. the whole not having a break in there. That can. So how would you write that one as an if statement? Mm-hmm. How would you write this one as an if statement? What would that look like? Well, it would probably be something like if month is equal to 12, or month is equal to 1, or month is equal to 2, see out winter. Else, if month is equal to 3, or month is equal to 4, or month is equal to 5, see out spring. You see where I'm going? And so you can kind of use that as another alternative way of writing a nested if statement. All right. Cool. Questions about that? How'd your switch statement go? Did you get that to work? Again, there are some limitations with switch statements. Another limitation, at least in C++, is that you cannot use a switch statement with strings. You remember, a string is something inside of double quotes, a collection of zero or more characters. So you can only use switch statements. You're probably typically only going to use them with things like integers and characters, right? So I guess you could technically use them with the double, but you can't use them with strings, and that's because technically in C++, string is not a built-in data type. In some languages it is, but not in C++. It's something that was added later. There's actually a string class. All right. Questions about this? All right. Okay, just for fun, let's this is fun, right? Let's there were a few more little things in chapter 4 that might be kind of interesting to test out. So I'm going to comment all this out, all this month stuff. I didn't show that assert thing in here, did I? I don't think I did. Or the question mark operator thing. Okay. All right. So, like I said, I hardly ever use this, but towards the end of the chapter, they mention terminating a program with the assert function, and it can be used to kind of test for hard to detect errors and issues. And a good example was divide by 0, right? And so like on page 236 of the 8th edition here, they have an example. So if you wanted to see this in action, well, we can just come up with one really easily. Test the assert feature. It would be something like this. You've got some variable Well, they just did a quotient thing. So they said like quotient. And then they had like a numerator and denominator. And then they said quotient is equal to numerator divided by denominator. And what happens when you try to do a divide by 0? Some compilers will automatically initialize things to 0. Some won't. I can't remember what code blocks does. It actually gives us an error. Oh, because I misspelled it. Numberator. Numerator. I misspelled denominator too. Denominator. I put demonator. Golly. Denominator. All right. So compiled. What happens if denominator is a 0? Let's say numerator is equal to 4, denominator is equal to 0. Make sure you save before you do this. What has happened? So my program just crashed. Okay, my program just crashed because you can't divide by 0, right? It's bad for everybody. So, including the compiler. You can divide 0 by something, right? If numerator was 0 and 4 and denominator was 4 or whatever, then you're just dividing 0 by a number. That's no big deal. The answer is 0, right? But if it's the other way around, that's a problem. So again, that didn't give me an error. It just crashed. So they're saying one thing that you can do, you can always test that, right? You could have an if statement that did something like this. If denominator is not equal to 0, then go ahead and do that division. Right? Gosh. Demonator. Sorry. Denominator. I should have chosen different variable names. Denominator. So it didn't crash that time because I tested, right? You know, and when denominator was 0, that didn't get done, right? So you can always test like that. You can also use this assert feature. So what would that look like? So over on page like 237, they showed that in action. They just throw this assert. What does that mean? They do this, assert denominator. And there's a semicolon there. That means basically if denominator is a positive number, then do this. But you don't have to do that. You could do something else, like denominator is not equal to 0. You know, you can put your whatever thing you want to test there. Assert. Oh, wait. Yeah. Yeah, and they actually showed that, a version of that. So assert that denominator is not equal to 0. Basically, that's doing the same thing. If that's true, then go ahead and do the division. But if that's false, if it's equal to 0, it's going to end the program, and it should output some kind of message. Now, I think we have to include, we have to include something for this. So we have to include assert up there at the top with our header files in order to use the assert function. So up at the top, you have to add number include assert, like that, assert. It goes at the top. Now let's see what it does. So it still crashed, I guess. Well, that didn't really help us all that much, did it? It still crashed, but now at least I know where it crashed. It said denominator not equal to 0 on line 271. So anyway, that's what that does. And so it's kind of a coding feature that you can use. You could throw that into your programs to try to troubleshoot certain things. I hardly ever use it. In fact, I don't think I've ever really used that. But it's in there. And so I wanted to show how it works. And they say that suppose you had used the assert function a lot and you were kind of done with the debugging and the development part of things and you wanted to go and take all those out. Well, you could go and remove them manually, just delete them. Or there's a line of code that you can put in that will basically deactivate all the assert lines. And it looks like this. You would put it, let's see. It says this must be placed before the before the cassert thing. So you'd have to put this at the top of your program above your include files. You'd put something like this. You'd put number define ndebug, ndebug, and that would stop the assert things. Still, it's going to crash. Notice it didn't give me the assert error, whatever. Anyway, that's that. Clear as mud, right? But like I said, I don't think I've ever really used that. So to fix that, or to get rid of, to make your program run again and not crash, just change the denominator to something else. And the other thing, I need to hurry real quick. Where's that conditional thing? There it is. Page 223. It was the question mark thing, if you remember that. You could do something like this. Let me come up with an example. Their example's not too bad. Let's just do that one. I've lost my imagination. So it's something like this. Let's say demo conditional operator. Suppose you had two numbers. Number 1 and number 2, and another variable like max. You could write this, if A, and we did this, right? If A is greater than or equal, not A, if number 1 is greater than or equal to, gosh, where is it? Number 2, max is equal to number 1. So we did something very similar to that. Else, max is equal to number 2. Right? And that's probably how I would write it. I like writing things as if statements. But you could do this. You could say max is equal to, and then your test, number 1 is greater than or equal to number 2, like that. And then put a question mark, and then number 1 colon number 2 semicolon. So that does the same thing on one line, basically. So the test is number 1 greater than or equal to number 2. That's going to evaluate to true or false, right? If it evaluates to 2, it will assign number 1 to max. If it evaluates to false, it will assign number 2 to max. That's what that does. It's just a different way of writing that if statement. Let's test it. Cout. Max is equal to max. Oh, that's not right. It's because there's no values in number 1 and number 2. 4 and 5. There you go, 5. Make sense? All right.